Here we'll go through an example of forming the two different enolates for a ketone. So we'll be starting with this ketone, 2-methylcyclopentanone, and we'll show the product if the ketone is exposed to sodium hydride and if the ketone is exposed to LDA. So if we look closer at this ketone, we reference the carbonyl carbon, and the two carbons bonded to that one are the alpha carbons. One alpha carbon has one hydrogen, and the other has two hydrogens. So this could form two different enolate products, and then of course in one reaction we have a small base, and the other reaction we have a large bulky base. So sodium hydride provides H-. This is a small base. LDA provides the lithium diisopropyl amide. So we have a bulky base. So if we use a small base, then we can form the thermodynamic product. This is the product with a more substituted double bond. And so that would result from removing this hydrogen here. So in that case, our products, we can show negative charge on that carbon. So we removed that hydrogen, gave that carbon a pair of electrons. We can show resonance here, where the oxygen owns the negative charge. That is the product. This is just resonance. So same structure, same molecule that's formed when we use a small base. So we're forming the thermodynamic enolate. Now if we use LDA, we're using a bulky base. So this reaction will favor forming the kinetic enolate, which is the enolate formed by removing hydrogens from an alpha carbon that has more possible hydrogens to be removed. So that will be removing one of these two hydrogens. So if we remove one of those two hydrogens, we now have a lone pair of electrons and a negative charge on that carbon. We can show resonance, double bond from that negatively charged carbon to the carbonyl carbon, and negatively charged oxygen. So LDA, large bulky base, forms the kinetic enolate, or favors the kinetic enolate.